So hello again everyone. This is as usual the writing of social network in Go, and this time I will try to do a voiceover instead of live commenting. So I have already recorded the video, and I will try to give comments on what I'm doing, and I hope that we will achieve better quality. So I show the inner workings of a social network. So we have, just as a reminder, we have a timeline that is shared for everyone, so everyone has the same timeline, and it is copied across all users, and it works in all browsers. So I try to make another user to log in, but as you can see, I failed to do so, so I register a new user. And yeah, I can't log in private mode because it doesn't save cookies. Yeah, as you can see, nothing happens. So I can't show that several users can be online in one browser, but it can be done actually. So yeah, I just wanted to show that login works, and as you can see, it does work. And we also have messages, and I fixed a couple of bugs there. So now you can actually see messages that are sent by you and that are received by someone. So I should now write message to user Chrome or Firefox in the near future. Also, we don't have working friends section, as you can see, but we have actual friends, but the code doesn't use it very much. And I will demonstrate that timeline actually works. So you write something that is put into a news feed for everyone, and I have made a live commentary in Russian as well. So I show that what I wrote in timeline is seen by everyone that is logged in, and it is seen live. And the messages that you write in the timeline are copied to every user that is present in the system, not only to your friends. And this is one of the things that should be done differently in real social network, of course. And I think that we will do this. Maybe I will do this off camera. But as for now, we have a lot of entries in our database because now we have test users. So yeah, and I will show this. So we write the timeline into timeline table, and as you can see, we have a lot of entries, and we have one entry for each user. We have a lot of users now because we have test users, and you can see that it is the same message but different user IDs, and there are two different messages. So I also try to explain the structure, but you should already know this if you watched previous series. So I write a message to Chrome in Russian, and I show that I indeed fixed a bug where we didn't see live messages. So Safari wrote to Chrome something, and it sees, and the reply is also showing in Safari, as you can see. So it works now. So what we will do in this episode is I want to refactor the protocol finally, and this is the WebSocket event handler. So this is the code where all the WebSocket communication is happening. So as you can see, we have WebSockets connection, and there are several that are established. And if we refresh a page, we can see that only one is pending, actually. So this is the events one. Yes. And when we try to get timeline, get messages, when we write a message, etc., we send and receive the frames. You can see them here. In Chrome, the green are outgoing and white are incoming frames. So these frames are passed in this code that is selected, and there is a very big if-else-if case where we examine the request type and launch the appropriate handler with we launch it in a separate Go routine, and it sends the reply. So it should be refactored because it has a lot of copy-paste code. So the way I would refactor it is to make something like web HTTP handlers, like static server. For example, when you specify some basic arguments list, and then you just process a request and don't really care about channels that are used for internal communication. And as you can see, we have two arguments for HTTP. It is one of which is a channel, and another is request that's not typed, and we want to get typed requests. So it would be similar but different. And as you can see, we have the same code, but it is different only with request types that we have. For example, for request get messages, we have this type of structure, and for other requests we have something similar, and for now it is basically copy-paste, and if an error happens, we call send error method. So it's not good. So we'd like to make some API to get rid of this repetition, and only to define callbacks. And if it is possible, we don't need to register them anywhere. So we would probably make methods on a structure that I will show in a moment. So as you can see, functions receive a lot of arguments, and a lot of arguments are the same. actually all the arguments are the same. So we can make a structure that would contain all these arguments in it, and we will only pass the actual request as an argument. Yes, as you can see, all this is the repetitive part, and if you want to add another parameter that is the same for all the handlers, you will need to change the signatures of all handlers. That is not good. So instead, we would make a structure, and handlers would be methods on this structure. And I will start writing this pretty soon. So sequence ID is actually used for communication in our protocol. So we can have several outgoing requests at the same time, and as all the handlers are started in different coroutines, then we can track which request is which response is answered to which request, and so we need the sequence ID. So the context will look as something like this, and received channel is not the best name for our context, so we will rename it to something like listener, and we send oh yeah okay, so I first get rid of it, but we'll see that we actually need this structure, so I will restore it. And instead of sending sending messages to some global channel, our handlers should just return the function, return the value, and one of value types that could be returned would be response error, and it would contain two fields: the message that is presented, that needs to be presented to user, and some system message. But actually we don't need the system message, so we will just log the error, and that's it. So it only has two fields. It's user message, and it is what we show to user as an error description, and the go error type would be logged to screen. So let's now look at our test, and you can see that we send a message, and in request get messages we receive one message that was sent, and it's all connected using WebSocket. So we have a small test case that tests the WebSocket communication, and it sends the basic two requests that are very popular and that are essential for every social network. It is send message and receive message. So a lot of people actually use social networks only as messengers. So this is why these are the first request types, and that's why they are checked as well. And we send message to user ID 1, and I showed it that we sent to this user, and in test we check it. Okay, so we have a request context type, but we would probably move it to another file. So yes, we have a lot of handlers, and yes, they all start with process and something, and the reply is sent in a very repetitive way, that we send some message into events flow, and if a coroutine panics, then nothing will be received, and user will have no reply for the specific request. So we first could move all the handlers to another file, so that we don't make too big main.go, and our IDE feels better, and in general it is better to separate different parts of application and put it into different files, so that the program can be understood easier, because we called the file handlers.go, and we will put all the constants, types, and methods there, so you can see them in one place, and you don't have to search it in main.go, and it's not really convenient to put everything into one file. So we'll move all handler specific structures, so we won't touch things like base event or JS user info. We will only touch the requests themselves and replies as well. So now I transfer the requests, and we will need to put replies as well. So here we go. We have put replies, and all that is left is the functions. So we will then transfer all handlers to a different file, and then start rewriting them. And all handlers are actually called not handle something, but process. And when we handle something, it is actually the channel communication instead of request handlers. So we have found all the process methods and put them into a separate file. Of course, it has a lot of imports that are used in main.go. We have to import all of them, and Go imports or IDE can do this for us and show which imports are not satisfied. And after IDE updates, and you can now see why it is not a good idea to create large files, so that IDE could refresh faster. And we leave only the request itself as parameters, and everything else goes into the request context. So this is how we want to our handlers to look. And yeah, I rename request context to WebSocket context so that you can distinguish it from others, and so that we don't use request as request word as request type and as request context as well. And of course we should return something, so we return empty interface, and this empty interface is then JSON encoded. It should be JSON encoded. So instead of using sendError function, we will just return the response error, not reply error, but response error actually. So I will fix it in a couple of seconds, as you can see. So yeah, I don't understand why there is no such field as user message, but this is how it should look. It is actually response error type. It's not the best name for a type, but what you can do. The reply error is the type that we send to the into the protocol, so we can't get rid of it. We need a different type response error. So all replies should have a base reply and type, and we can't get rid of it sadly, so we should just return the reply get messages structure, but we also could return response error, so we'll stick to empty interface for now. And all the information that was passed to as parameters, all information that was passed as parameters into our handler is now contained in the context, and so we don't need to use sequence ID too much. So it's only one place in reply itself where we use the sequence ID and reply type, and we don't need this event flow communication. We just return the reply and that's it. And this way, if as I said, if function panics, then we also return the reply. And as you can see, reply already was empty interface, so we don't mess anything up. Yeah, so the types are the same, and this is how our handlers should look, and the only thing different would be the request type. And sendError is not really required here as well, but it can be used still. So we just simplify the interface by making it to return the response error instead of doing this manually. So we return cannot select message. So we return user messages, and it is cannot select messages in our case, and now we don't need to log error ourselves, we just return it. So sadly we can't get rid of this part, even though we could deduce the reply type and sequence ID from reply. we will have to leave it for now, but maybe in future episodes we will find a way to get rid of this manual thing as well. So all the other requests would be the same. So we just copy paste the common type of code and put it where we need it. If we have no error, we don't return it, so nothing is logged. And if we have a system error, then we provide it and it would be logged automatically. So as you can see, the transformation of handlers is pretty simple, and it makes code much better. It is shorter and it is more robust this way, because it cannot miss panic. And message is different, of course, so this is what we need to copy. And if we had a bigger project, this process even could be automated by writing a program that would do something for us. And in this case, we do not send any messages to events flow, so that user doesn't receive anything. And this will be fixed as well, because we no longer can skip sending reply to a user and just log the message. So we will do the same thing here. We'll just return error and message that something went wrong. I forgot to update the signature, so we will do it now. And in process get users list, I forgot empty interface, so I should probably update previous one as well. So in all the handlers, everything looks pretty much the same, but there is only one place where, or there are several places where we actually need to send events into the events flow, and send message is one of them. So you'll see in a moment. So this is a pretty routine operation, and as I said, it could be automated, but it would be done faster if we do it by hand. But if the project would be much bigger, much larger, then it would make sense, and we could write an automated tool to do this kind of refactoring. And as you can see, here is one of the places where we sent two events. One of them is event user reply, and we just return it as usual. And so the other one is that we send event about new message. And this event should be delivered to two users, to user from and user to, so that the person who wrote the message receives his message back, and user 2, target user, also receives the notification about new message. And we don't have receive channel in context, and it is required for event flow, so we will have to introduce a listener in the context. And you can see that these events are processed in the events dispatcher Go routine, and for a new message we call handle new message, and it sends two events. So it's this method just illustrates that we really send a live notification to two users if they are online, of course. So if they are not, then we send notifications only to those who are online. So we can get rid of this. We need this control event, so that users receive live notifications. And I really don't like the receive channel name, so we will use listener here as well. So it's just the events listener for, I forgot why it is needed, but it is how we determine the user. So this is the same for add to timeline, as you'll see. So this is a very routine operation, but in case of add to timeline we have a small twist as well. So I'll show it in a couple of seconds. So we have different event type. It's a timeline event, and it's different in that it is sent to all users that are online, instead of sending it just to. But other than that, there is no difference. So we can see that new timeline event has different handler, and there is actually a not really accurate test for capacity, and the receive channel. So the listener is just a channel of messages that are printed to user. So we have replies and events, and so listener is events channel. And instead of checking capacity, we can do this select and empty case and empty default, so that if it blocks, then it would go to default case and it won't block. And the listener map is not a global variable, it's just a map of listeners into users, and so we send events to all event listeners, and all event listeners are all online users. So this is how process add to timeline works. So we need to send an event here as well. And other handlers would be refactored at increased speed, as you can see. So as it is all the same, I don't need to explain anything there, so there is nothing new here. It's just a little bit of manual work, and sadly in this case ID won't help you. Because we just change the way it works. So we change we remove copy paste. So copy paste removal is usually very satisfying, and it can be done by hand. So as you can see, it's really easy, and we finished with this. So we have our handlers, and now we will need to find a way to call these handlers properly, and for this we will need to use reflection. So I'll now talk about how to implement it using reflection and get rid of this copy paste. So as you can see, we have a lot of copy paste here, and I just get a part that is repeated, and I extract it, and we also have the code that does launch handler itself, and I commented because we can't reuse this code, and the codes that is decoding the user request is reusable, but we need to put reflection here. So what we really need to do is to write some reflection code, and first we should create a context for our methods. So I'm looking into the documentation on how to create a basic type, and so how to get type of our pointer to the structure. So as you can see, we create a type, reflection context, and get an element here, and get method by name with process and the request name. So, and we also need to convert the message to method name, and I named this function convert underscore to camel case, and of course we don't need the request prefix as well. And then we need to call this method on a structure that we allocated, and then I try to find the proper way to find the argument types. And so this is how it's done. We get first we get a function, or no, we get a type context. We get a type on the reflection function, and we should specify two arguments. First is this receiver, that is CTX, the WebSocket context, and second argument would be the request itself. So we need the second argument type here. So I should write it now. So we get an incoming argument with index 1. It's in argument, and we get its type, reflection type. And then we need to create an actual we need to create an actual actual value for this type. And I moved the OK check lower so that we don't try to dereference nil, because we check for it. So what we need to do here is to create new value. So new in reflection is almost the same as if you would just write new and specify some type, but instead you specify the reflection type. And I search for interface on how to return the value, the real value back, and you call method interface to do this. And this way we get the empty interface value that represents the request that was here. And then we need to decode this, as you can see. So we constructed, we analyzed the callback that needs to be called for this request type. We got the first the type of first argument, and we created a new structure for this, and we tried to decode the request. And if we succeed, then we create a WebSocket context, and we have values for all these fields. So we just fill them in, and user ID and name is got from this session, that is user info variable here, and listener is the channel where we send the replies, and not only replies but all events that need to be delivered to user or need to be delivered to the system instead. So the handler should send all the messages to this listener if it wants to. Okay, so we should now call the function, and we do it by calling the call method, and we specify the array of values and this slice of values, reflection values. So first one would be the receiver variable, so it would be the WebSocket context, because it is the method, it's not the function. So the first value is receiver, and second is user request, of course. And we get the slice of output values, and in our case it's only one. It should have only one element in it. So yes, as you can see, it returns the values that the function returned. So we call this. And then we should decode the answer. And it is done pretty much the same way as before. And the function could return either the proper response of the required type, or it could return a response error. So we should check for it. So it's response slice, and the first element would be response slice 0, and we cast it to empty interface, of course, to get a real value, not the reflection value. And we should then analyze its type and do proper things in case of error and in case of anything else. So if there are any error messages, then we print it, and if there is a user message, then we send it to user. So the structure should always have the user message, so we only should check for error that's not nil. Okay, and the default would be to send a response. It is done in a similar way as in send error, so we just send this response to the global channel. We send this reply, and it would be sent to user this way. And we should also set the response type fields in the handler itself. So that's all that is needed here. We just send it to event flow, and that should be it. So it's a generalized way to do this. But there is one small issue, that our callback could panic, so we need to put into go routine, not go routine, but to separate function, and write the defer func recover, so that we could return something in case of handler panic. And not exit the go routine and even application itself. So we should do something like creating a new response error, and that's it. So we could recover from panic, and you do this by calling recover. And if panic happened, then recover would return an empty interface that's not equal to nil, and it would have the value of the value that was passed to panic. So the user message would be internal error, as it happens with any internal server error that is unknown to a web server. And given that recover value is just empty interface, we convert it to string by using font sprint. It's a very generic way to convert any value to a string, but you can do it in another way if you want. But we need to return the error value but not the string, and compiler should say about this in a moment. Okay, so now it should be compiled, and we need to run test for this. Oh, but before we do this, we need to write the callback that I was talking about as well. So yes, we need to write the method convert to underscore to camel case, and it's not really that complicated, so let's do this. It should get string and return string, of course, and the format would be as in comment, so we say something request get messages with underscores, and we return the camel case variant. So we split the incoming string by an underscore, and then we create a new string slice that would be the result, and then we capitalize the first letter. So we actually know the result length, so we could specify it. And now we iterate over the strings array and make the result. Sorry. So the first letter would be capitalized, as you can see. So to uppercase. No. Yes, the rest would be lowercase and first would be uppercased. So yes, we specify the slice starting with first byte, and for the first part we specify a slice of one letter, of first letter, and we join it by empty string and return. That's our result. So it is a pretty simple function, and we need to we need to write a functional. We need to write any test for it, but I'll do it in a functional test because we already have it, even though we could do it in a unit test as well. But to save time, I will just write it here. So it would be test and convert underscore to camel case, and it should just check that the description works. So we get the string from the description, and we check that everything works as expected. So we pass it the original string and check that it matches the result. And that's our test. So we write it in a proper format, we write the response first and vice versa, the expected first and result second. So it would be done something like this, and of course you could use any test framework that you would like. I don't do this because I don't have much experience with them, and it's not really needed for such simple thing. So compiler shows us that we don't put a proper type. I'm sorry. So that we don't return a proper type, and it should be not a string but an error, and package font already has the method to return error, and there is one more error, and that's it. So we have an example of a missed response. So this code didn't have any error, any sending of reply to user there, and that was one of the reasons why we did the refactoring of user handler. So sequence ID is not in test, and our test shows that something is wrong with our parsing, and we should find out what happened. So I examined the code that scans the request format. And first I try to add a debug of the requests that we send in our protocol, but we will see that everything is okay. So it shows that the requests were sent properly, and that there is no corruption here, but still somehow it doesn't want to recognize this message, and it worked previously, so it is very strange that it doesn't work. So we need to find the reason of that, and there could be plenty of reasons why it could happen. But we can see that sequence ID is not int, is returned only in one place that I highlighted, and we could do something else. Instead of printing the request, we could try to print the data that is read by a decoder, and one of the ways to do this is to use treader, and it's not located in buff IO as I try to do. So split function is not what I want. It's located in io.treader. So in a moment I will see this. Excuse me. So yes, here it is. It's a treader, and what it does is to copy everything that is read from the WebSocket in our case, it copies everything to another stream that in our case would be just stdout, and it returns a new reader that has all the output, so that transfers all that was put into the WebSocket. So it just returns you the same stream as before, but it also prints what it sees if you specify stdout as an output channel. And we could also add some marks in our test so that we can then compare the original request and what was received by the server, by the other end. And as we can see, it is completely the same. So obviously problem is somewhere else. So something is clearly wrong here, but it should be related to what kind of changes we have done, because the same code worked before. So there should not be any errors in this code, but still, let's verify this, and I print all the intermediate variables here. The request type would be request send message. Request ID string would be this 0. It should be 0. And yeah, I trim the request type, so I print it in every value. And we can see that values are bad even after the first request. So the request type is correct, sequence ID string is correct, but request type is this second request type is not correct. So it is body of a request instead of a request type. So something is wrong here. And I try to find out what is incorrect here. So it seems like the first request has some error probably and is not paused until the end. And we just don't see an error because it is sent to user. So we add a debug print to send error in a moment. So this is this is method where errors are sent to users. So we could also print it so we can print it here, and when we try to call the process something method, we get an invalid request type. And obviously we do have process send message method, so something is wrong with our reflection code. So we check the callback name first, which is request camel. And as you can see, it is send message, and the callback name would be process send message. I'm sorry. Be process request name, process send message, and obviously something is wrong with the reflection itself. So I try to print all the methods here that are all the methods on our context, and we get 0 methods. So something, yeah, we get 0. So something is clearly wrong here. And the type doesn't have a star, so I try to add another one, and we get a panic instead. So it's really not so much better. But we get a correct number of methods this time. So something is wrong here, and it takes some time for me to understand why. Reflection is always very tricky, so if you didn't understand too much, then it is okay. So I remove the panic handling method to get the stack and information about threads, and I add sleeps so that the test doesn't exit, and I see where panic happens and which line causes the panic, and I see that the must be exported method does not allow us to call this call the methods that we are trying to call, and it means that we need to uppercase all the we need to make all the methods public, because it is considered to be from another package, because reflection is different from our main, so it can't access to these methods. I'm still trying to find the reason why it either has 0 methods, or it gives us strange panics. And yes, I spent some time debugging this, and now I can tell you what is wrong. So first thing that I did incorrectly is to call the element. The element method removes 1 star from the type. So when we created a context reflection, we got the WebSocket context type instead of star WebSocket context, because we called element, and of course we didn't need to do this in this case. So the type is good there, and when we got the reflection method type, so the type of an argument, we need to remove a star, because we create a new element, new object, if you would say. So new adds a star when you specify the type. So we got the request type that would have an additional star, and that's not what we want. And the other thing that I also done is to specify the address of user request instead of specifying user request itself. So that's JSON decoder could unserialize values properly and create a new value there. And so when you specify something to new, then you should use elm method if you need to get the resulting type properly in this case. And as you can see, everything works now. We get the replies, and I remove the debug messages. I also added the decoder decode here to the invalid request type handler, so that we don't mess up the protocol, and we continue decoding next requests even if one of them failed to an unknown type. We don't spoil the request. So we see now that I removed all the debug here, and our replies are correct, and they are checked in our functional test. And so we successfully finished refactoring the protocol, and now I'll show you that the application works. Not only the test, the small functional test, but everything actually works. So I send a message to different users, and you can see that they are received. So I sent messages from different browsers, and timeline, users list, everything works. Works as before, so I can say that it is a huge success. And we have done the big refactoring of our handlers, and now they look much better, and you don't need to register them anywhere, so you just create several types for your request and response, and that's it. So thank you for watching, and let me know how what you think about the experiment that I have done, so that we can now get both Russian and English versions. And if you want to get something implemented, or if you need some help, please make comments in the video and I'll answer them. Thank you.